Welcome to the Biotech Startups podcast by Exceeder. Join us as we speak with first-time founders, serial entrepreneurs, and experienced investors about the challenges and triumphs of running a biotech startup, from pre-seed to IPO, with your host, Jon Chee. In our last episode, we spoke with eMalick Njie about founding Genetic Intelligence, its mission to combine AI and genetics to tackle diseases, and the challenges of founding a company. We also heard about the personal sacrifices he made, the eventual breakthroughs that earned recognition from the National Science Foundation, and the lessons he learned from his journey. If you missed it, be sure to go back and listen to part 3. In part 4, we talk with eMalick about the mission of Ecotone AI and the company's focus on leveraging AI to decode the human genome and tackle rare genetic diseases. We also discuss Ecotone's approach, including their use of diffusion transformers to model genomes and generate synthetic genomic data, the importance of intentional company building, and the strides Ecotone is poised to make in the field of AI and genetics.
Now that the stars are aligning and you've healed, the transformers are online, the pandemic's over, things are starting to look like the elements are right now. How did you kick this off? What is Ecotone's mission and focus, and what are the short-term, medium-term, and long-term goals for Ecotone?
So yeah, wonderful. Thanks for asking the question. Ecotone's vision is for a world where genetic diseases are cured, right? And we think that this is like a world that could only occur with the use of artificial intelligence to help us understand the human genome. Just to read the numbers again, rare genetic diseases encompass a wide range of diseases, about 10,000 of them. The list grows every day as we find new ones, impacting about 1 in 8 people. These diseases range from childhood blindness to neurological disorders, to developmental disorders in the body and so forth. So it's like a wide set of diseases, but they all share in common a change in the genetic code that is passed on through families that causes significant illness. Because these are genetic diseases, we operate within a 3 billion element space of the human genome. This is like a very high dimensional space that the techniques that we have had up till now just are unable to understand. And AI models seem to have this potential to be able to look at this language as a first language, understand what this ATGC mystery life code is. This is the fundamental code of life itself. And for us to be able to get insight as to what's causing these diseases, we have to hopefully read it as a first language. And what does that success look like? Our success looks like us building a model that we could input in genomes from a particular group of individuals that have like a disease. And then that model gives us back a location within that genome of that group of individuals that is causing the disease. And with that information, we could then go ahead and design remedies such as CRISPRs that are tailor-made to be able to modify the genomes with a correct version of the gene and thus cure them of the disease. So very similar to what we're doing in a laboratory, injecting the correct versions of genes into animals. We were able to do that because we knew that the location of those genes and thus could create the correct versions and inject it into them. We want to do the exact same thing in people, and use technologies like CRISPR to do so. So we do not see ourselves as becoming a medical company or a CRISPR company. We are an AI company. The information that we find is immensely valuable to like CRISPR companies, for instance. So in the future, like somewhere down the horizon, we'd love to engage in conversations with partnerships with the innovators in that space. As for today, we are laser vision on just building the best AI models to understand genetics. And building those models involves taking some risk as to the types of models that we take. I'll just maybe I'll dig in a little bit deeper here.
Please do.
So within the AI space, there's high level things such as like supervised learning, where you tell a model what labels or descriptors of what it's looking at. There's unsupervised learning where you don't. There's semi-supervised where you have, basically in between those two first spaces. But deeper than that, you find yourself with looking into autoregressive or diffusion-based networks, or autoregressive transformers versus diffusion-based transformers. Have you ever heard of these? Come across?
No, but I'm interested in learning.
Yeah, so those are shaping the world right now. So autoregressive transformers or models in general, they don't have to be transformers. They are regressive. So at any one point, it looks backwards, like regresses backwards to figure out what's going on, and it's automated. So automated looking backwards, right? The AI revolution that we witnessing within the GPT space is all autoregression. So OpenAI's ChatGPT, Anthropic's Claude, Mistral from France, those are all autoregressive models. We have like a transformer whose job is to just look at any position within a chain of tokens to guess the next one, use that information prior to it, really, regressing backwards. And there's all sorts of tricks to make them work really well, including attention and transformers, so forth, right? But there's a different frame of thinking, which are called diffusion-based approaches, so which include also diffusion transformers. In this case, instead of looking backwards, what you do is you have, let's say, an information space. Could be words, or could be, let's say, a picture, because let's use pictures because those are the most successful versions of this. Let's say you have an image of like image of a cow, and you degrade the picture a little bit, so it becomes a bit blurry, and then you ask your neural network to memorize that. Right? Then you degrade it again a little bit more, and you ask the neural network to memorize it again. And you degrade it again, and you have to memorize this, right? And then you keep doing that all the way until it's just gray pixels, right? So now you have this neural network that has from when it was like absolutely clear all the way to when it's now a nonsense. It's memorized how it became degraded. Well, you could flip that neural network and say, well, you know how it was broken. Tell me how to put it together.
Whoa. Okay.
Right. Yeah. So it's taking the entire information space at once, though, right? Because it's the whole thing is being degraded at once. It's not like autoregressive ones where you're looking back. Like in the case of like a picture, the autoregressive one would like look at one pixel and look at all the pixels behind it. Then go to the next, like a line scan, go to the next pixel, like on a TV, like go to the next pixel. Right? This is doing it all at once, right? So if you're like, hey, can you recreate it? And it does it, which it does, right? So it must have picked up like learned how this thing was put together, and particularly things that are close to each other, like that are locally close to each other, and also things that are far from each other, long distance relations. So like a picture of like a cow, local information would be like the black and white spots on a cow, right? But then long distance information would be, if you give it a bunch of pictures of cows, like, you always have like ears and tail in the same body, but not on grass.
Yeah. You
don't have like a random tail in the grass, or you don't have like a random nose in the grass. Like these are always together, right? So long distance connections are right, like a global connectivity of the cow itself.
Yeah.
Right. So this is why it's called diffusion, because you first diffuse, like from the initial image, you degrade it a little bit, then you degrade it a little bit. You like learn how to break the glass, and then once you do, like, okay, now reconstruct the glass for me. Right?
That's so wild. That's, I just like know that, and as an end user, I'm like, this is awesome. But it's
Exactly.
interesting to hear. It feels like magic, honestly. It feels like
exactly
green magic.
Exactly. So I just described to you how Midjourney works, as well as all the other image gen, as well as all the video models that are coming out. They all are working on diffusion, right? So we're creating a company and trying to create the best AI models. We have a choice. Can we do autoregressive? Can we go diffusion? Right? So we are putting a bet on diffusion transformers because of their capacity to see long distance relationships on both sides. Right? We look at the genomic code, which is multidimensional and it's non-linear. So we choosing like diffusion architectures and building these transformers from the ground up to like destroy the genome sequentially and then recreate it.
That's actually wild. And it's just so funny because I was thinking about how, like, when I was at the bench in like pre-2011, how times have changed like drastically. And it gets me really excited for these tools that, exactly like you said, the CRISPR people or whoever it may be, to be able to utilize these tools to exactly to be create curative products. Exactly what is, when you said in the C. elegans world, you're just constantly just doing you're basically just curing day in, day out. And if we can see that manifest in humans, that would be, and with the help, obviously, I feel like we're in the early innings. We're not there yet, but it's incredibly exciting to just at least try to look past the horizon and see what the potential is. And I can feel this door opening, exactly what you said, and they can't close it. But for the better, which is really awesome. And so, to get into the company building and, kind of right now, and maybe, I know you guys have been getting active. I think I've seen you guys got a ton of early achievements. And can you talk a little bit about the momentum you're feeling in these early kind of company formation days for Ecotone?
Yeah, exactly. So one, we're building a company with intentionality. From the lessons from genetic intelligence, each hire is very, very, very vetted. So the team is small. It's five, different levels of five, right? Because it takes time to get people on board, to make sure that the vision is carried out from the risk or what I experienced from genetic intelligence. And we were lucky enough to win a few awards. And the framework of choices actually starts to, if you choose the right sort of direction or momentum, you start to see very important and very powerful things come out of it organically. It's sort of a signal that you're on the right, your boat's fed in the right way, when you're out there for building frontier models. So a great example is once we chose diffusion transformers, we're like, okay, down the horizon, we'd like to build a model that is able to read a genome as a first language, right? What can we do now that has immediate value with a start? So, okay, we're interested in rare genetic diseases. So these diseases, because they're rare, doesn't mean that not many people have them. In the United States, it's less than 200,000 people for the disease to be classified as that. And many of these diseases only have 5,000, 4,000 people that have the disease. And if you ask how many of these individuals have been genome sequenced, whole genome sequence, we only work with whole genome sequences, just a heads up, by the way, from genetic intelligence to this day. How many of them actually been sequenced? Now you're talking, dozens of them, maybe, sometimes even less. So where we need to have more data, because AI models need tens of thousands of examples for them to work. for them to be able to learn. So like, wait, we have this idea with this diffusion transformer. What has been done is quite remarkable with them in other spaces. Well, so Midjourney and some of the other companies doing image gen, they've been able to make portraits of human faces like that look just like real people, but they don't exist in the real world. But they could make as many of them as possible, right? They carry all the features that we think of as a face. What does that look like if we have the equivalent in the genomic space? Right. So they use a diffusion transformer to make those human faces portraits. We use a diffusion transformer. What if we could use a diffusion transformer to make human genomes of populations with rare genetic diseases?
Interesting.
Right. Now we could have synthetic genomes that look just like real genomes or indistinguishable, but carry all the features of those real genomes. But we could move from dozens of genomes, or maybe hundreds of genomes, to thousands of genomes. And now we're talking, because now we can now start putting that into AI models to actually learn, right? So the example that we're working on now is with sickle cell anemia, which is a rare genetic disease. I would say it's the most famous one. So we've been in conversations with St. Jude's Hospital. They have a repository of genomes, whole genomes from kids that have sickle cell, and the number of genomes they have is 807. And I think that's the largest repository of sickle cell anemia genomes. That is not enough to train an AI model. We need tens of thousands more, right? So we're in dialogue to see if we could use these genomes for this model that we're working on today called DNA Sora. And so it's named after Sora, the video engine from OpenAI that I'm sure you've seen, which is based on a diffusion transformer. And it's called DNA Sora because it's going to be, instead of taking video data, it's going to be taking genomic data. And its job is to take from the seed data of like the sickle cell patients, it's 807 genomes, take those and be able to make new genomes, these synthetic genomes in the thousands that the benchmark is that you should be able to distinguish the real genomes from the synthetic ones. Well, synthetic ones and the real ones, they should be close enough that we can't tell a difference, yet different enough that they could all be unique, right? And then now we could start doing full-on AI training in like a larger model that is the model that is going to give us insights for curing diseases, not just sickle cell, but moving from there to other diseases as well.
That's like I'm not from the AI world, so forgive me if it feels like the sci-fi future. Like it was just, I'm like, holy shit, like because there is a data problem, right? And like you're exactly right. I was just like, okay, all I've heard is that there's mountains of data that is necessary to kind of increase the fidelity of the AI, and I love this approach where you're able to kind of bridge that gap. When you went from like, okay, here's how many people there are in the world, United States, actually whole genome sequence, you're just like, you have like a kernel. It's like a kernel. Yeah. So there's like a massive data gap here. So that's really inspiring and also like just clever and innovative to figure out how can we, actually bridge that gap. And I can see it just like you start here, that's like a beachhead, and then you can start applying it elsewhere. It's like if it works here, we'll hope that you can just continue to be, you'll find the kind of the path on every other, genetic disease. And also sounds like, and your St. Jude's is like, an institution too. So you're like working with these large institutions, which is probably a very unique experience as well. And again, I'm going to imagine now that instead of the early days of AI, just like, this is what AI is, probably the conversation with St. Jude is like, oh, no. Generally, I've interacted with AI now, so it's less of the Sisyphean kind of like boulder up the hill. Like, God, like, the movement is here now. Maybe it's a little bit more downhill. you're pushing this boy downhill now.
Yeah. Yeah. It
Whoever
still
it
works,
is,
but, you know, we
still work. Yeah,
move much easier. The friction coefficient has changed.
exactly. Maybe not purely downhill, still work, but
But
at least there's a baseline familiarity. So that's really, really exciting. And honestly, the you talked about building your company with intention and making sure you're getting the right hires, which will then proliferate the culture that and the vision that you're seeking out. And as you are looking forward to maybe just 1-2 years, and maybe I'll extend this to you personally. What's in store in 1 to 2 years time for you and Ecotone?
yeah, thank you. So we believe that if we follow the pursuits that we're doing, value will naturally be will follow. Will come, right? And funding as well. So for me and the team, it's making sure we stay aligned to what we're doing. We're building frontier models. And DNA Sora is what we are focused on now. That's like our primary point of attention. I would hope that in like a year or two, this model will be built. It will be able to generate human genomes that are indistinguishable from real genomes. This, of course, is going to shock the industry. You may notice like lots of companies that sequence people's genomes and then keep it internal as like in these internal repositories, and then charge others to access them. The most classic example is 23andMe selling their database to Genentech for $300 million. And that's the one that leaked. There's much smaller versions of that. So that whole space is hopefully will not exist. Privacy concerns and so forth that come along with that are completely obviated by when you use the synthetic genomes. A frame shift of thinking that I hope will lead in using DNA Sora as like a means to train large models using synthetic data that gives us insight as to real genomes, the information in the real genome, being able to read it as like a first language. This is of immense value. So companies that are working within the same space as we are, they've also been seeing similar things. I'll highlight one of my favorites, InstaDeep. They came out with a model, I believe called a nucleotide transformer. They did that together with NVIDIA. And that model performed well. It was able to, without giving any labels, was able to determine what difference between different known genetic elements are, like promoters, stop codons, and so forth. Like it was given no information and was able to do it. Like, this is what I mean, reading this language, right? So right now we are probing the models for like genetic words that we do know, right? And we're like, oh, do you know this? Like, I know it, but do you know it? And the AI model's like, yes, we do, right? But at some point, we're going to move from words that we do know to words that we don't know, right? And we're building models like DNA Sora to enable that to occur, right? So us to get this larger insights, being able to query the genome for words that we do not know and for meanings that we do not know, which is really immensely impactful for disease, knowing like the causes of diseases and the etiology of diseases, but also in general, of course, for understanding what life means. In a year or two, I hope we start scratching at those words that we don't know. Right. And then, of course, value follows that, right? So investment, interest, and so forth follows things like that when you lead in with that sort of robustness.
That's amazing, and also like so optimistic for the future, and it's just honestly really cool. Like it's just really cool because I think kind of a lot of science, my parents aren't like biology or bench science or anything like that, but they just like when they look at how science is from the outside looking in, they're just like, yeah, it must be a well-oiled machine, super efficient, just like cranks out like, miracles. But like, honestly, it's like a lot of science is a lot of brute force. And what I'm kind of sensing here is that like we can work smarter, not harder, and start, rather than just trying to brute force mechanism everything, because like that'll only go so far. So really, really cool to hear what you guys are up to. And well, one thing too, I want to say thank you so much for teaching me a lot here, like, and being patient with me. I feel like I've leveled up just having this conversation with you. Because I hear about all of this in the abstract, so I'm like, but now I feel like and hopefully the listeners too, can take away something as well about what this, AI can be a buzzword, but like as I've learned right now, there are like real world like impact and applications of this, that we can see in our lifetime, which is super awesome. So in traditional closing of the Biotech Startups podcast, there are 2 closing questions. And thank you for your time, by the way. You've been so generous. The first question is, would you like to give any shout outs to anyone who supported you along the way?
Oh man, where do I start? It's a long list, but of course, all the supervisors that I've had, from Wendy to Alice to Dave, Jake, Marty, thank you all for dealing with this explorer and my curiosity. And I also would love to give a big thank you to, of course, my family. My mom, my dad, for giving me and my sister space to just ask questions at abundance. And then, of course, my best friends, particularly one of them, I'll name Wilton Williams, Dr. Williams. Dr. Wilton Williams, we met when we weren't doctors.
Yeah.
He was at University of Florida with me, and he now is a professor at Duke Medical School.
Cool.
Just amazing human being, from Kingston, Jamaica, just like a natural learner, and was instrumental in me moving throughout graduate school with all of the different pitfalls that comes with, and particularly for reading a proposal to my
Yeah. Like specifically. Thank you.
He was just amazing at highlighting things that could be improved there, as well as encouraging me to pursue such, what seemed to be an impossible task at the time. So thank you, Wilton. He's got an excellent lab now. I think he's got like 15 people, so they're doing quite well. So yeah, I should stop over there, but
no, I love hearing this, because it's like as lonely as entrepreneurship can feel, but you're like, having the support of friends and family and mentors is incredibly important. And hearing your journey too, it leads to massive inflection points in everyone's journey. And I love looking back on it and just really like, again, it's like, it's rare to take a moment to just like connect all the dots, and see how it kind of like ended up shaking out. So I love hearing that. And the last closing question, if you can give any advice to your 21-year-old self, what it would be?
So actually, I will first say that I'm going to thank the crew in New York here.
Yeah, of course. Yeah, of course.
Thank your future friends.
Yeah.
Greg, Mike, Brooklyn here is like a pretty vibrant community of entrepreneurs, to the investors, of course, from Paperspace and so forth. My 21-year-old self, I would say, I was at MIT at the time. I think the best advice I would say is just keep on and take more naps.
Yes. Honestly, that's like, nowadays, I was just like, man, I was running on fumes. Like, take care of yourself. Like,
take care of yourself.
Don't forget to take care of yourself. It's like you can lose sight of that sometimes when you're so busy. So, and honestly, that's the advice I would need to hear as well. So, eMalick, thank you for your time. Thank you for teaching me and the listeners so much about this exciting future that we're kind of living in the now. I could go on for hours and hours with you, and maybe we catch up over a beer the next time I'm in New York. I'd love to learn more from you again. So thank you again for being so generous and coming on the podcast.
Jon, thank you. This has been an absolute pleasure. It's wonderful to chat with you, not just discussing what Ecotone is doing, but what I've been through, but also really wonderful to hear about you and your journey. I feel less lonely with some of, I now know the frozen aisle has some hidden gems in there.
Yeah. and this is the beautiful thing I'll say too about this podcast, and also the internet. Honestly, it's back when this lonely experience you was a long time ago, the world felt far less connected, at least internet wise. So it was easy to just feel like you're the only person experiencing that. But again, like a kindred spirit, you're not alone. And I'm glad we were able to reminisce about it. And to brighter days, right? And for anyone else who's listening, again, take the naps and also
keep on going. Take the naps and keep on going.
Keep it going. Well, thanks again. I'll talk to you soon.
Thanks, Jon.
Take care.
That's all for this episode of the Biotech Startups podcast. We hope you enjoyed our 4-part series with eMalick Njie. Be sure to tune into our next series with Neela Patel, Chief Business Officer at Bonan Therapeutics. Neela is a seasoned scientist and business development executive with more than 30 years of leadership experience in drug discovery and development, project and portfolio management, and pipeline development through internal and external innovation. Prior to Bonan, Neela was the Chief Business Development Officer at Good Therapeutics, where she orchestrated the Roche acquisition and spin-out of Bonan. Previously, she was also Executive Director of Corp Dev at Seattle Genetics, Director of Search and Evaluation at AbbVie, and Director of Global External Research at Abbott. Before AbbVie and Abbott, Neela spent the first 16 years of her career in drug discovery, advancing many drug candidates into the clinic at Pornyard Pharmaceuticals, Genentech, Sugen Pharmacia, and Roche Bioscience. Her deep expertise in drug discovery, business development, and management makes her conversation one that founders can't afford to miss. The Biotech Startups podcast is produced by Exceeder. Don't want to miss an episode? Search for the Biotech Startups podcast wherever you get your podcasts and click subscribe. Exceeder provides research labs with equipment leases on founder-friendly terms to support paths to exceptional outcomes. To learn more, visit our website www.exceeder.com. On behalf of the team here at Exceeder, thanks for listening. The Biotech Startups podcast provides general insights into the life science sector through the experiences of its guests. The use of information on this podcast or materials linked from the podcast is at the user's own risk. The views expressed by the participants are their own and are not the views of Exceeder or sponsors. No reference to any product, service, or company in the podcast is an endorsement by Exceeder or its guests.